Hello everyone. It's December 2016, and I'm very happy today to introduce to you Dr. Nathan Connor. Nathan's a faculty member here who replaced Dan Hoosman in the UNL Teacher Preparation Department for our ag teachers. And so he also assumed the role of the Nebraska Agriscience Career Development Event Superintendent, and will be putting on that event for your students come this April. It's a very popular event. I'm happy to see a lot of teachers on the call today. And so with that, I'll turn it over to him. We'll be doing a lot of interactive things, and so you might want to make sure that your screen is big or full screen to see some of the smaller details that he'll be showing us today. With that, please feel free to ask questions at any time. Nathan, I'll turn it over to you.
All right. Thank you, Matt. Hello, everyone.
They muted themselves.
They muted themselves.
Yeah.
All right. Well, like Matt said, I'm Nathan Connor. I am the newest faculty member here as a teacher educator at ALEC. I'm also the superintendent for this event for the Agriscience CDE. Several weeks ago, I sent everyone out an email over the listserv that had some documents that will be very helpful when you prepare your class and your students or your team for this event. We're going to be referencing some of them today, but I do want this to be interactive, so please ask questions. So prepare to take your mute button off so that you can talk, so it's not just me talking. The first thing I want to mention is that when you think about preparing a team, we really want you to think about doing this as a part of your Introduction to AF&R course with the whole class, so that you're following the standards, you're following the curriculum, and you're not just teaching a group of 4 students that you're bringing to a contest, because we don't teach the contest. It's a part of the 3-circle model. We want SAE, FFA, and classroom laboratory to all meld together. So first thing, if you'll notice, I sent out, or Matt sent out the agenda for today. Matt's going to change the screen to it so we can look at it together. Are we there, Matt?
Yep, they're seeing it.
So if you notice, we're going to do several things today. First of all, I want us to talk about the Agriscience CDE, just so everyone's on the same page and comfortable with the event. That's the overview of the Agriscience CDE. Then I am going to demonstrate how to prepare the students for the practicum that will take place here at UNL, and that's the Maintaining Clean Water practicum. And with that, we'll learn how to prepare agar. We'll actually spread water on an agar plate through the spread plating technique. We will look at different bacteria that have already been plated, and we'll learn how to count them. And we will then look at the calculations that the students will be expected and required to do on their event that day. And then we have time for questions. But please know the questions can come at any time during this workshop. I want to answer the questions as you think of them, so you don't forget and don't get a chance to ask your questions. So if you would, are there any questions before we go any further? Okay, so if you would take a look, Matt, show them the 2016 Agriscience CDE overview sheet.
Okay.
This sheet is what I emailed out several weeks ago, and it is also posted under the Agriscience CDE on the UNL website. So if you'll notice, there are 3 components of this event. There's an exam, there's a Practica A, and Practica B. Let's start with the exam. The exam will be a 50-question test. It's going to be in multiple choice format. So when preparing your students for this exam, the bulk of the questions, 35 to 40 of the questions, are going to come from the core material. That core material is from units in the 4th edition of the Agriscience Fundamentals and Application book.
Put it underneath here, and I'll just...
Which we're going to put under this document cam so you can see it.
I think it'll be in the thumbnail view for everybody. Oop. Spitting.
We're trying.
Yeah.
That book information is in the Nebraska Career Development Events document that is online, as well as emailed out to all the teachers in the states. But on the Nebraska Career Development Events document, it says 2016. And on that, it says natural resource systems, because that's the rotation we're on for the core development event. So the core areas are units 7, 8, 9, 10, 11, 18, 19, and 20. So 35 to 40 of the questions are going to come from 7, 8, 9, 10, 11, 18, 19, and 20 in that book. Now the other additional questions, 10 to 15 questions, are going to come from the optional sections that we use every year, so the optional units. And those units that we use every year, no matter what rotation we're on, is 1, 2, and 4. But if you notice in the Nebraska Career Development Event document, those optional units are included under every year's rotation. So if you just go by what's under natural resources systems for 2016, you will cover every unit that material could be taken from and used on the event. That should cover all bases there. So this test will be done individually. The students need to bring pencils. Please remember that. Have them bring pencils because we're not going to provide them for all the participants that we're going to have. And all 4 scores from each one of your 4 students, since this is a team event, will be used in the scoring of this event. So to find your rotation time, that's all posted online and was sent out in the email, I believe, as well. Any questions about the exam? Okay, moving on then. The Practica A. This is the home-based practicum, which is the career report. If you'll notice on the Agriscience CDE page, you'll notice under Practica A that you use Unit 4 of your textbook to help prepare the students. This is the unit that's over careers. Another item that you want to use to help your prepare your students is the lab manual that goes along with that same book. It's the 4th edition Agriscience lab manual.
Put it underneath the camera there.
Which we're going to try to display here.
Have it face you, and then that won't be the right way up.
In that manual, it's very important to note that you need to pay special attention to exercise 5. It has a great big wheel on the page. The students need to be familiar with that. It's going to help them learn about careers, but you as an instructor or the students are not turning in that wheel from that laboratory activity. It should be used in your classroom and in preparation for the career development event, but you are not submitting that. You are going to submit the career report postmarked to me by March 28th. Is the last day to postmark. That way we will get those back in plenty of time to grade them and have the scores for the actual event on April 6th. And my address is in the document that I emailed several weeks ago, and it's also online. So all that information is there for you, and it's in the Nebraska Career Development Event Agriscience document. The exam is 100 points possible. Any questions about Practica A that's done at home?
A question I have, Nathan, is
good night, young lady.
What if I'm not sure? By March 20th, I guess everyone needs to be registered for the event. But if I have alternates, do I send up to 8 papers to you, or can I send all my classes papers to you? What do you prefer?
Go ahead and send alternates if you're not sure. I would go with the guideline up to 8 would be fine. I don't think it will benefit us if we send the whole class. Hopefully, if you send 8 alternates, you will have a team out of 8. But please do go ahead and send them by the due date. So then whoever you do bring can participate. If there's no more questions about that, where I want to spend the most time today is on Practica B. That is the practicum that the students are going to do as a team here at UNL the day they're here. This year, since we are on natural resources, this practicum involves counting bacteria that come from local water sources. And it's kind of a cool, fun, exciting thing. And over the last week, I have been plating bacteria in my office here and showing Dr. Bell and probably getting half the floor sick with these bacteria we're growing. But hopefully that will be beneficial for you and the other teachers that watch this. So there's a couple things you need to note on this 2016 Agriscience CDE sheet is that the exercises that the students are going to do come from two places. They come from exercise 8, the maintaining clean water from the lab manual, as well as from a Carolina biological lab set. And all that information is on those documents. Even I've included the bacterial pollution of water, that's the set, and it's number 652704 from Carolina Biological. I would highly suggest that you order that kit. I believe it's about $55. Even if you just order one, it's going to be very, very beneficial in preparing your class and your team. One of the reasons it's beneficial is because it comes with a Carolina Bacterial Pollution of Water Kit manual. This has a teacher's manual, which gives you a background about bacteria. It tells you exactly how to do the lab, and there's also a student guide that gives specific instructions for the students. It even has the math calculations, some of which will be used on the practicum the day that students come to UNL. So I would highly recommend purchasing at least one of these sets, because that is where the practicum activity is going to come from. Now, before I get started, this practicum activity, the day of the lab, the students are going to count bacteria. They are not going to be expected to culture the bacteria or plate the bacteria. That's already going to be done by pre-service teachers prior to this event. However, in the classroom, I suggest that you work with your class and teach them how to make agar, collect water samples, plate bacteria, count bacteria. And I'm going to kind of walk through you the different steps of this today. It is in the instruction manual, very detailed, but I do think it's beneficial to see it done. Although some of the steps we're going to omit because we're not in a lab or a science classroom, we're in Matt's office, and we do not have Bunsen burners and hot plates or stoves in his office. So are there any questions before we begin? Okay.
Dr. Connor, I do have one question.
Yes.
This is Chris Spath. What was the name of that kit once again?
It is, oh, where did that go?
It's right here.
It's right here. It is the bacterial pollution of water.
Thank you.
And Chris, that's on the trifold. I had that on the screen a second ago, but it's also on the trifold. It's at the bottom of the Practica A column, but it relates to actually Practica B.
Thank you.
It's where it can fit in on the page.
Yeah.
It is there. So one thing that I want to mention, I think is very important when you're working with the students in the classroom. We want to emphasize safety and proper sterile or aseptic technique when we're making this. So one of the things that I'm going to do here and that you should do in the classroom is I would use bleach wipes, and you always want to disinfect the surface. And it's going to tell you this in the instructions from Carolina and in the lab manual as well. And so after that's disinfected, and these will be provided the day of the contest. Rubber gloves will be provided for all the students to use if I can figure out how to put them on. And then we will also, actually, the students will be required to wear safety goggles. So I'm going to put them on here. So before we actually look at the bacteria that we cultured, if you order this kit, it's going to come in a box just like this in the mail. So once you open that, it's going to have everything you need to make agar plates. It's not going to come with pre-made agar plates. It's going to come with 2 bottles of agar. they see this, Matt?
Yes. They can see you, but maybe stick it underneath here. Yeah. For some reason, I can't get our screen to come up live. Okay.
It's going to come with a bottle of McConaughey Agar, and it's in that kit. So if you order that kit, it will be there. And this agar is going to be used to try to culture coliforms or E. coli. Then it's also going to come with a bottle of nutrient agar. This is going to grow general bacteria. The students will not have to identify what type of bacteria is growing from this media. So in this kit, the step we can't really do here is, this is in a solid form right now, and you have to basically make it liquid like Jell-O. So how you can do this is a couple different ways. If you have a stove in your room, you could put this bottle in a beaker filled with water, and you're going to bring this to a boil. And it needs to boil for about 30 minutes. You can also do this with using a Bunsen burner. So once this boils, it's going to become liquid. It needs to cool to, I believe, about 55 degrees. That number is in the manual. Once it cools, you are simply going to pour it into an agar plate. Now, these agar plates come in a pack like this, and they are sterile. So you want to try to maintain that as much as possible. So when you take one out, you're going to have just a clear plastic plate. And you'll have a lid and a bottom. So what you want to do is you can put the plate on the ground, you can lift the lid up with one hand, and you are, even though I just did the incorrect thing, you're supposed to always keep the lid facing down to prevent contamination. So then you'll take your agar medium that you've turned into liquid, and you are going to pour it into the plate. I'm pretending now because we did not do this step in Matt's office. So you pour it into the plate, and in the instructions it tells you how much to pour in there. So once you do that, it takes about a half hour, and it's going to harden like Jell-O. You want to let it cool, and then you can use your agar plate once it is cool. That's very important to make sure. Now, one of the things with this is if you don't get the temperature just right, it may become too liquid, and your plate may not turn out just right. For the CDE, the students are not making agar. For the CDE, I am not going to make agar either. I am going to purchase pre-made agar plates, which look like this. Matt, can you show the camera for them?
Yep. There we go.
So you can order them from Carolina. You can order a package. They come in packs of 10. This one is McConaughey agar. How you can tell that is McConaughey agar is this purple, red color, the dark one. And then let me show you the nutrient agar. These, I believe, are about $21 a pack of 10. I would recommend, if you have the funds, when you are working with your class and working with your team, to go ahead and, we have one leaking, to go ahead and order the pre-made ones, because if kept properly in the refrigerator, these will last about 6 weeks, I believe. The exact dates, if I'm incorrect, are in the guidelines. And the company Carolina ensures that they are ready to use and they will be effective. So any questions about making the agar if you're going to do it that way? Okay. So the next step is, the first thing you have to do is you have to get water. I would suggest getting water locally near your school. It could be a stream, it can be a pond, a lake. It could even be a puddle that's stagnant. But you can do this in a few ways. You can have your students collect it the night before. But the thing you want to be cautious of is Carolina recommends that the water doesn't stay in the test tube for more than 16 hours. So you want to get it fairly close to when you're actually going to plate the water on in the Petri dish. So the kit comes with sterile tubes, which Matt's going to show us here. So the little plastic test tubes are sterile. Once you unscrew the black lid, you risk contamination. So all you're going to do to collect water is when you're at your water source, you're going to open the lid, you're going to put it down, try not to touch rocks or mud or anything like that. You're going to put it down in the water. It works real easy, especially if it's a stream that has a little current to it, and fill it up. There is a line at the very top that you can fill it to. It's about where my finger is. Just fill it up and then immediately close the lid and screw it on. Now, it is suggested that the only time you have the black lid sealed tightly is during transportation, so when you're in the car or walking with the sample. So once you get back to the classroom, even if it's going to be a couple hours before, if you put this in a test tube holder or prop it up some other way, it is suggested that you just slightly unscrew the cap, leave it on there, just let it be loose until you're ready to use the sample. So before I show you how to plate a sample, we're going to watch a couple YouTube clips that we have sent you in the email, but these are clips of how this is done in an actual lab, and then we're going to show you how you probably do it in your classroom.
Okay. It's this one.
Yeah, it's on the
oh shoot, I need to actually share the Safari screen. These are the same links that were provided in the initial email and that attachment that I sent out right after school as well. And so I'm going to share my browser window with all of you so we can see that together. Second. Oh, my computer's struggling with all these.
Are there any questions while we're waiting on YouTube?
Oh my gosh, I guess I haven't never shared the audio before. If they see the video but not the audio, can you describe it? Okay.
I can. You have these clips if you want to go back and use them in the classroom, which I think would be a great idea. They're both very short clips. I believe they're both under 2 minutes, 1.5 minutes. Matt, if you would click on the spread plating, that's right there, yes. Okay. This is the spread plating. This one's actually longer, but we're not going to watch all of it.
This protocol incorporates aseptic technique.
That's not working.
Spread plating aims to separate microorganisms contained in a small sample volume.
We don't have to use them.
Resultant color.
Okay.
We're okay. We're okay.
Is evenly across the agar.
So basically,
equilibrate a plate.
Okay. Sorry guys, that didn't work.
About that.
It works in the links, so.
Yes, it does. Okay. So basically, what you're going to do is you need to get your McConaughey Agar, the dark red or purple plate. You can set it on the ground. You've already bleached your surface. You have your gloves on. You have your safety goggles on. Same thing, your clear white one, that's the nutrient agar that grows general bacteria. And you're going to set it lid side up. So you set them on the ground. So what you have to do first is the kit comes with micropipetters. We can probably just leave it on the document can for a minute.
Yep. There you go.
So the kit comes with micropipetters that are sterile and they're sealed in plastic. So the first thing you are going to do is you're going to have your sample near, and I do not have a test tube holder here. So Matt's going to put his glove on and hold that. So once you have your test tube, you are going to undo the package. And you're going to use a new micropipetter every time for every plate that you do. So you take it out, try not to touch anything with it. You are then going to open your test tube. You are going to fill it with water to 250 microliters, which is about where my finger is. If you buy the Carolina kit, it tells you exactly where. And it actually says it in little teeny letters on this pipette. So you'll push the bulb down, try to go in the center. You'll get about 250 microliters in the pipette. Then what you're going to do is you're going to reach down and reach one of your plates. You are going to take the lid off like this, go in the center, and you're just going to drop the water, let it flow, and then immediately take your lid and put it back. And you're going to do that again for your second one. So let's pretend we've already put the water on all our plates that we're doing. Now, the kit also comes with little plastic hockey sticks, which are called spreaders. These, again, have been sterilized and are in this package. Once you open it, you risk contamination. So the handle end is the long, straight end. The hockey end part is what you're going to use to spread that water evenly on your plate. So you have to open the package. Take one out, try not to touch anything. Then you take your lid. Well, I would just hold your lid upright with your hand. But if you wanted, let me show you two ways. If you hold it upright, you put the hockey stick spreader in the center, and you just start going back and forth through the whole thing. Now, probably a little better way that you'll do is you can set this lid straight on the table, but it does risk a little more contamination, but we have bleach, so we're using precaution. So if you just drop the water, you take the spreader, and now you are actually holding the plate, and you want to put that evenly all throughout there. If it's uneven, you might have clumps of bacteria growth. And what you're seeing, the funny looking stuff on this agar right now, these actually froze in our refrigerator today. Yeah, they're little pieces of frozen chunks of the agar. So that's not good, but that's what we have right now. So one of the things, if you watch the YouTube video, in a lab, they would take this agar plate and put it on what they call a turntable, which is basically a circle, and it sits down in it. And then they take their hand and they spin it. And then as that Petri dish is spinning, they take the spreader and they just go back and forth like this while it's spinning, and that helps it become very even. So if any of your science departments or you have them in your classroom, I would highly suggest that. It helps make it even. Or you could probably make something fairly easy that you could spin the plate on and then spread. What questions do you have about plating the water on the agar? Okay, so once they are plated, you want to incubate the bacteria at room temperature. It's important to note that you don't want to use an incubator or a heat lamp or any hot or heat source like heat pad, because it's going to promote bacteria growth that can harm humans, or the likelihood's more likely. So we want to avoid that in our classrooms and for our career development event. So you want to plan your plating exercise about 2 days, 48 hours or so before you plan to count bacteria. What's going to happen is at about 24 hours, you're going to start to see bacteria growth. Matt's going to put up a picture that he took last week when we plated some bacteria on December 7th. And I'm going to show you what bacteria might look like at approximately 24 hours of growth. Let's start with the clear one. That's the nutrient agar. Can everyone see that plate?
Ed's nodding, yeah.
Okay, great. So if you notice, each one of those little bumps are colonies of bacteria. So on that particular Petri dish, there is many colonies there. But that's only at 24 hours of growth. So you're going to see a different looking agar plate potentially at 48 hours. And it's going to look even different at 36 hours. I'm going to pull out the plate from December 7th that was in that picture. And Matt's going to put the document cam on for us. But I'm going to leave it in this plastic bag because these are many days old and they're really smelling. And we don't want to get sick. So I don't know how well you'll see any of this.
Set it down as far as we have, so it's maybe. There you go. Nope, that didn't do it.
So on this Mechanicae auger, which is looking for coliforms, can you see the real dark specks on there? The dark specks, like one by my thumb there, those are coliforms or E. coli bacteria. If you were here, you would probably have a better view of it, and they're pink and purple. So when the students are counting bacteria on the Mechanicae auger or the purple auger, pink auger, they're going to be only counting the coliforms or the E. coli, those bacteria colonies that are pink and purple. They're not worried about all this other clear colonies. Right now, on this plate, we would never use this on the contest. It was deplated on December 3rd, and it's the 9th. So it's way too old, and it needs to be disregarded. But I wanted to show it as an example for you guys here today. So, Matt, would you go back to the picture now that you took at 24 hours of the red one?
Yeah.
So, the reason you want to look at the colonies at about 48 hours, it is unlikely, according to Carolina Biological and in the bacteria we've grown here, that you're going to see any coliforms, the pink, purple type colonies, before approximately 48 hours. There was none of them appeared at 24 hours. So if you have your students just look at the Mechanicae auger at 24 hours and they're looking specifically for coliforms or E. coli, they're not going to see it most likely because it hasn't developed yet. It takes a little longer. So Matt, if you go back to your other picture there. So to count these bacteria, Carolina recommends that the students, when you're preparing, pick up the Petri dish and on the bottom of it take a permanent marker and actually mark a little dot or an X somehow over each bacteria colony. That might be wonderful when you're practicing in your classroom, but with the amount of contestants, we can't have the students do that the actual day of the event. So you are going to need to help them figure out some type of system so they know which colonies that they've counted. Maybe if they think of the Petri dish in 4 quadrants in start, but they're going to have to be very careful where they hold it because if they turn it, it's not going to make sense. But they're not allowed to write on the Petri dishes. And you don't want your students to count half of the bacteria twice because they're going to have an inaccurate count number. So let's look at actual Petri dishes on the document cam that are at 48 hours.
John, did you have a question?
Yeah, do you think you could put those, when I've ever done this or seen it done, I've seen the Petri dish actually have that on there.
The quadrants?
Yeah, and that would kick a lot of butt, and because I don't know if that's something that a contest can't have, but it just makes sense to already have that done.
Right.
To equal the playing field, and I don't think it'd be that hard for, because Matt has taught some of those students, they can make X's on Petri dishes with permanent markers. I think that's something they probably learned as a skill in the block or whatever. Could they possibly do that before we get there?
Let me look back at the rules, and I will let you guys know.
Okay.
I don't see a problem why we can't put Do you just mean put 4 quadrant draw lines on the Petri dish?
Yeah, not count them, just put the little X.
Yes, for the quadrant, yes. Yes, we can do that. I don't see any problem with that. That would make it a lot easier for everybody. Any other questions? That was a good one. All right, so this is the Mechanicae agar, and it's the purple agar. So can everyone see some pink or purple colonies there? There are some larger ones here. There's a pink, that's the coliform. There's one there. There's a bunch on here. There. So for this agar, they are going to count the coliform or E. coli colonies, the pink and purple ones. Sometimes they get pretty dark too on the agar. These right today at 48 hours are a little lighter. If you were here, they're kind of pretty. But if they're out a few more hours, they may turn darker, is what I've noticed. So they would just count those. One thing we'll talk about in a little while is each plate is plated with 250 microliters of water, and I'm going to give that information to the students the day of the practicum, and you have that information already that was sent out to you today, because that's going to be important for the calculations the students have to do to know what we plated, how much water we put on each plate. So if I switch over to the nutrient agar, there's a lot of colonies. Now the students are going to be able to pick up the dishes. They're going to be taped with parafilm, which, let's see, is this stuff right here. And if you don't want to purchase parafilm, because it is kind of expensive, you can just use clear tape as well. But when you're working with your class, you do want to make sure you tape them up so that the students can't get into them and risk getting exposed to the bacteria. Okay. So also, one thing we will provide the students the day of the event is a magnifier that the students can use to help count and help see the small bacteria. And it's pretty easy. The ones we have little stands on them. They can set them right on the dish, and they turn left and right to focus in better on the bacteria. So if you want to train your students on how to use these little magnifying glasses, we ordered these from Carolina Biological as well. Okay, so after you're done with your plates, you need to disregard them. Don't keep them around the classroom for a month because they're going to continue to grow for a while. So, all right, man.
And just another clarification.
Yes.
How old are these again?
These are 48 hours. We plated these on the 7th.
And so, and this is approximately the type of growth the students would expect to see at the career development.
Yes.
Okay. So when the parafilm's kind of over like this, do you expect students to be kind of just pull that back, and because they do the entire surface,
yes,
correct?
They do the whole surface. What we will try to tape it up a little neater than I have them here, and we will also try to already have it spread back to the very edge, so there is as much clear top on both sides exposed as possible, because we don't want to have the students peeling back the tape, because a couple things can happen. They may apply more pressure with a thumb and crack it and cause exposure, or over time they may unwrap it, and then if it's dropped, we could have potential exposure. So we will try to make sure that the tape or parafilm is pushed back as much as possible.
And so on this, what colonies do they count?
On this one, if the general bacterial colony, so everything that's a bacteria colony is counted on the nutrient agar, which is this clear agar here. So everything is the colony. There's 1, 2, 3, 4, There's tons of them on here. And you can also use the pictures. Maybe Matt can send out the pictures he took on his phone, because you can also use those. Those are at 24 hours, but they could help your class and help your team train. And there are also pictures at different hours online that if you don't have the materials or want additional practice materials, that you can find online and help train your team. Any questions about that?
So this is a team portion of the event. It's probably difficult for more than one student to count the Petri dish at a time. How many Petri dishes, can you just recover that? Are there for students to do?
Let me grab my little sheet here. Yeah, so there's 4 students on a team. There's going to be 2 Petri dishes that the team is going to have at their station. One purple one and one white one, which is the nutrient auger. So there's 4 of them. There's 2 dishes. On top of the dishes, when they're at the practicum, there is going to be some questions that the students have to answer as a team, multiple choice answer type questions. And it talks about on the overview sheet where those are going to come from. And I may end up giving them some materials to read as a team. And if I do that, those questions will come from that material and be questions that the students can derive directly from that. That won't be based on something else if I choose to give them additional material to read. So there's going to be 2 dishes, 4 students, and questions to answer. And they have 45 minutes to do this, so there should be ample time for everyone to count. And I would highly encourage that they compare their answers to see if anyone's close to each other or way off base, so they can decide collectively as a team if they are on track to what they think is accurate. So let me show you the form that's going to look very similar to this, or the same for the most part, that the students were going to receive. If you look at, you guys have this. Matt emailed it out to you. So there's observation form, and there's a Petri dish A, which here it says, and I'll do the same thing, general bacteria count, lighter agar, so that's the nutrient agar. That's going to be the dish the students are looking for general bacteria. So they're counting every single colony on that agar dish. And then it says it's 50 points. And so here's what the students have to answer. After culturing the sample, we counted blank colonies of general bacteria. So I'm going to make this number up, and it's it's not necessarily accurate. If they came up with 100 colonies, they're going to write that there. It is the count that their team decided on, 100 colonies. Now the student has to do some calculations. So they have to tell us the total general bacteria count was therefore X out of 100 microliters. Now, I've given them that 1,000 microliters is in 1 milliliter. They're going to have that, and you can work with them on that. And I also have here, each Petri dish was plated with 250 microliters of water. And above this, which they will not have, but you do to practice with, is a couple examples pretty much taken out of the Carolina manual that you can purchase, but I've given you some stuff here to help you. So a student who had previously reported 100 colonies in a 250 microliter sample would now report 40 colonies. So that they've done 100 divided by 2.5 to get 40 colonies. You can practice with the students how to do those calculations, do the cancel out methods. You guys can do that with them. So they'll have to put that answer right here. Now, after that, because different places want this reported differently, we have one more question, one more conversion. The total general bacteria count was therefore blank per 1 ml. So once again, they know that there's 1,000 microliters in 1 ml. It's there for them. It will be there the day of the test. They know that we started with 250 microliters of water that was plated on the Petri dish. So if you look up under example 2, you have an example. A student who had previously reported 25 colonies per 100 microliters would now report 250 colonies per ml. So what they've done is they've multiplied by 10 to get 250 colonies. You can do this out with the cross multiplication the cancel out method, so they can see how the units cancel out and transfer. I'll let you guys do that. But those examples are there, so you can work backwards from them with your students. Once they know the conversion factors, they're going to be pretty simple if they were trained on that and comfortable with that. And they're going to do the same thing for Petri dish. For the second one, the Coliform bacteria, which is the purple one. So they're 2 dishes, and they'll be able to count. Are there any questions? Hopefully, having this information will be beneficial in your classroom, and it'll let the students see and become familiar with what they're going to see the day of the event, so they're not caught off guard with the format and the form that they're actually going to have to fill out. These are the exact 3 questions that are going to be there the day of the event. So if you use this and practice with this, I would think that your students will have an advantage over a chapter that maybe didn't use this information for whatever reason. So that's pretty much what I've planned for today. I'm happy to talk to you guys and take any questions you have.
Don't forget, you need to unmute yourself if you do have questions.
I unmuted. Could you hear me, Matt?
Yep, go ahead, Joe.
Well, yesterday I had trouble with unmuting it, so I wasn't able to talk. But this was the team practicum part. Will they do something individually there as well?
This is the team practicum part. The individual practicum's the career report that they're going to do at home and mail in by that due date.
Right. But as far as anything at the practicum here as a team, they won't do anything individually?
No, it's all team.
All right.
They can talk. They need to talk.
The exam is individual.
The exam is individual, but that's a different rotation. That's
right.
a different time.
Mm-hmm. They did a good job going through all that.
Well,
I hope I can pull that off.
You know, I really can't stress, you can order the Carolina kit. It lays it out perfectly, detailed explanations. And I didn't talk about it, but it talks about what happens if too many bacteria grow, what is a bacteria lawn, when all you see is like a solid ice skating rink of bacteria, basically. Because that could happen when you plate these in your classroom, but you can't count that, so you just got to get rid of it. And it explains the difference of gram-positive bacteria and gram-negative bacteria, and that you're growing gram-negative bacteria as the coliform. So there's a lot of educational material that you should use in your course and help train your team, because some of it could be on the team exam portion as well. Because if you'll notice on your sheet, I've indicated that things come from the Carolina kit as well as the exercise in the lab manual, which is similar. But for the actual practicum, we're following what you just saw today.
Nathan, Roger Lechtenberg here at Ainsworth. Can you hear me?
Yes.
You mentioned that you had already sent out a schedule of schools. Did I misunderstand that?
The schedule, I believe, is only on the website.
Okay.
It's for, right, Matt?
Yep, I'll pull it up.
Matt's going to pull it up for us. That tells you which round you're in.
And so that's all of the career development event schedules are set. We don't see any major modifications at all to that. We've updated the district rounds and everything. And so my computers are struggling with all these windows open. See if we can't just pull that up for everyone's benefit. While I'm doing this, Nathan, talk about where, like, what you might expect a science laboratory to have in regard to all of this. How to maybe dispose of bacteria plates once we're done with them. What are some best practices you'd recommend regarding that?
As far as what you need to do this, the kit's going to come with everything you need. Where you could get into some challenges is if you're going to make your own agar, then you're going to need some way to melt down the agar that's in the jars that come in the kit. So you're going to need Bunsen burners, or you can even get by with a hot plate, or if you have a stove in your classroom, you can do it on a stove with putting it in a beaker, or some other type of container that can withstand boiling water. You know, afterwards with the bacteria, I would put it in a Ziploc bag, and if your science department has any means of disposing biological hazards, kind of like you do needles that have contaminants, I would try to get to your science room, because they'll probably have the red containers that you can put these dishes down in, because they are full of bacteria. Some may or may not be harmful to us, so you really need to try to dispose of them properly through those red containers, which should be in your science classrooms, I would think.
Thanks, Nathan. As you can see, I finally pulled up the schedule. And so as Dr. Connor was talking a few minutes ago, the written exam takes place during section 1, which begins at 4 in the afternoon on Wednesday of the convention. And then we broke it out by districts, and those districts rotate every year, so it's probably different, should be different than what you had done last year with your students. But they last each of them an hour long. And so if you're in districts 9 through 12, you're lucky because you get to show up once. If you're in any of the other districts, then you get to come back and join us again an hour or two later.
Set it up like that.
I'm sorry, if someone said something, I missed it.
I said, thanks for setting it up like that.
Oh, yeah, that works well for you, doesn't it, Roger? Good questions, though. Thanks. What else? Well, as I'm sure all of you are aware, all the rules for the career development events are on the website, and you can go to each individual one. These are the updates, and then at the bottom are the relevant documents that we have. I think what Dr. Connor and I were talking about was to share the document with the example, Petri dish examples and the math calculations, and that's so everyone has access to that beforehand. But again, the tips that are at the top of that sheet will not be available for students the day of, as he was describing earlier. And of course, if you have more questions too, you can contact Dr. Connor through his contact information here on that website as well. Well, are there any other final questions or comments or suggestions that you might have regarding this event? If not, thank you very much for spending the time. And it took a lot of coordination. He's been working on this for about 3 or 4 weeks since we've initially asked him to do it. And if this worked out well for us, we might try to do this with more career development events in the future and try to make them as hands-on as possible, as much as you can with an online format. But,
thank you, Matt. Thank you, Dr. Connor.
Yeah.
You're welcome.
Thanks, guys.
Yeah, thanks, everybody.
Yep. Bye.